Okay. Is this where I'm supposed to be?
Yes.
Okay. So here we are looking at finding limits analytically, and the catch is they're piecewise functions. Okay, so for instance, as you look at A, the limit as x approaches 1 of g of x. And then look at g of x. It's defined to be x cubed plus 1 when x is greater than 1, and it's defined to be x plus 1 when x is less than 1. So the idea here is this, I mean, we have to figure out what that limit is. And there's always the whole does it exist thing, okay? Because at 1, it's a piecewise function. We could have, I mean, I see a line here, and I see a cubic equation. Those could somehow be joined together, right? Like we could have, you know, the line, and then it could pick up like that, okay? We could also have the line, and then we could have it pick up like that and them not be connected. Okay, so that's what we need to figure out is what's going on with this limit. With that in mind, what do we keep talking about? The limit from the left has to equal the limit from the right. Okay, so we're going to look at that, and especially because it's piecewise functions, I'm going to say the limit as x approaches 1, and I'm going to go from the right. And officially, I mean, I can say of g of x, because this whole thing is g of x, yes? If we're looking at the limit as x approaches 1 from the right, like what we were doing yesterday, we can plug the 1 in. Where do I plug the 1 into?
Maybe greater than 1, right?
Yeah. And so the greater than 1 is
X cubed.
X cubed plus 1. So mathematically, we're going to be doing what? 1 cubed plus 1. What is 1 cubed plus 1?
2.
2. So that's the limit from the right. Let's do the same thing and check out the limit from the left. The limit as x approaches 1 from the left of g of x. What's going on is we approach 1 from the left. We're on the 1 plus 1 piece, x plus 1. So 1 plus 1 is 2. Well, what did we just show? Limit from the left equals limit from the right, and together they equal 2. So our limit equals 2. So I'm going to say two things. First of all, the statement I'm going to make, and this is AP notation, which I'm trying to demonstrate here. The limit as x approaches 1, it doesn't matter which way you put this, from the right of g of x equals the limit as x approaches 1 from the left of g of x. Okay, so there I'm just stating what I've proven. They both equal 2, so they're equal to each other. And so we can now say, therefore, I'm going to use those 3 dots, the limit as x approaches 1 of g of x is equal to 2. Now, that might be a lot more than you want to write. However, you hit a free response problem. You know, this is the type of notation that is official notation. Okay, so this is what I'm demonstrating here is just good old, I'm going to call it AP notation. Okay. So B is a similar example then. We want to find the limit as x approaches 2 of h of x, given that h of x is defined to be that. So what do we need to do? Find the limit from both ways. The limit as x approaches 2. I'll go ahead and say from the right of h of x. Now I'm writing h of x. You could also write in there the piece of the equation that's true. Okay. What piece of what are we doing here?
The bottom one.
Okay, we want when x is greater than 2 because we're saying from the right. So this is going to be the negative of 2 squared plus 4 times 2 minus 1. Do that math for me in your head.
I got 3. I got 11. Oh, the negative's outside of the parentheses.
It's the negative of x squared, so you're going to square the number and then do the opposite of it.
So 3.
Yes? That's why I said both of you do it in your heads, because I wanted to cover that mistake there that I knew someone would make.
I made that mistake many times last year.
It's one of those things. It's unusual if you have no one make that mistake. So, I was waiting for it. If not, I was going to point it out. But okay, check the other side. Limit as x approaches 2 from the left on h of x. Now we're plugging into the other one. 2 squared minus 4 times 2 plus 7.
I'm sorry, does that say -3?
Here?
Oh, that's equals 3.
It's a funky equal sign.
Sorry, I'm not wearing my glasses today.
Ah, there's the problem then.
Yeah.
I'm like, it's not that bad of an equal sign, is it? Jeez. Okay. And?
3.
You get 3. So, the two limits are equal. Therefore, the limit as x approaches 2 of h of x is equal to 3. So I am going to make the statement that the limit as x approaches 2 from the right of h of x equals the limit as x approaches 2 from the left of h of x. Therefore, the limit as x approaches 2 of h of x is equal to 3. Okay. We're going to keep we've got multiple different techniques to look at today. So I'm really just going to kind of keep moving through techniques. Piecewise, you've got to check out both sides and make sure they're equal. Okay. Example 3, factoring or cancellation technique. Probably already familiar, but we're going to practice because there's a little bit of good factoring practice here to do. So the limit as x approaches -4. Okay. One thing I would suggest, try plugging it in at first to see. I'll be honest, I see something like this, I tend to factor automatically just because I'm guessing it's, there's going to be a problem. But, it doesn't hurt to try direct substitution and then factor if necessary. Because maybe there's a chance it's not necessary. If I plug in -4 here, -4 squared is 16. 2 times 16 is 32. Minus 28 minus 4. I'm seeing a 0 on top. 16 plus 4 minus 20. I'm seeing 0 on bottom. So guess what? It's 0 over 0. That's an indeterminate form. We don't stop there. We've got to find a plan B. Plan B is going to be to try and factor. So, the limit as x approaches -4. Okay. Where's the factoring you know?
Mm.
Denominator factors into?
It'd be x minus 5 and x plus 4.
Okay. Numerator. And sometime we should review product of AC, but I'm going to say you can shortcut this. Okay. First of all, 2x squared. What does 2x squared have to break into at the front of each parenthesis?
2x.
That's going to be 2x times x, yes? Now, what does that 4 break into? You technically have two options. 1 times 4 or
2 and 2.
2 times 2. Now, this is where I use my clues. I have an x minus 5 and an x plus 4 down here. Right now, I have a 0 over 0. If something doesn't change, I have a problem. We're looking for there's probably going to be a factor that cancels. So we're probably saying that this is going to be a 4 and that a 1. Now, don't just assume, but is my logic making sense? Okay, so then if I check my signs, it needs to multiply to be a negative 4. So out of 1 and 4, I need a positive and a negative. I need, check here, I need my middle term to come up to be a 7x. So that means these two are going to be a positive 8x, while my insides are going to be a negative 1x. And it works, doesn't it? And guess what? X plus 4's cancel. Okay? So, I don't know if that's quicker than product of AC for you, but it is for me. So, I now have the limit as x approaches negative 4 of 2x minus 1 over x minus 5. Okay? Now what?
Plug in.
Plug in.
One.
I agree. Okay. Now, if I was going to skip one, I should have skipped A. We need to talk about B. Guess what's going to happen? Well, you can guess what's going to happen if you do direct substitution. Looks like you're going to get 0 over 0 again. Okay. Yeah. So we need to look for a plan B because direct substitution doesn't work. Well, technically, we're in the section that says try factoring. What do we know about factoring here? You're going to start with the easy part, the denominator? I mean, you know, get it done. What's the denominator factor into?
4, negative 3.
X plus 4, x minus 3. Okay. Do we remember how to factor the numerator?
It'd just be it'd just be like 3. No. Yeah, 3.
So, doesn't it? X minus 3.
That's going to be one of the factors.
Cube root. then x squared plus 9. I think it's been that.
You're getting there. You're on the right track.
Yeah.
Okay, so we have these rules, a cubed minus b cubed, and there's also a cubed plus b cubed, where the first factor is just the cube roots, keeping the same signs, okay? The second factor is a trinomial. Always starts off a squared, always ends b squared. The middle term is the cube roots multiplied, but with an opposite sign. Okay, so that's just little notes for yourself because that's supposed to be known knowledge at this point in your life. Okay? So, we think about the cube roots. The cube root of x cubed is x. The cube root of 27 is 3. And you guys were both already onto that fact. Okay? So I'm looking at a minus b. So my a and my b are going to be the x and the 3, right? So x minus 3. A squared plus ab plus b squared. So it works out to be x squared plus 3x plus 9. If I've done my math right. And then, of course, what happened by design in this problem? X minus 3 cancel. And you're ready to, I mean, you can rewrite the limit, but could you also just go to direct substitution if you wanted to?
Yeah.
You could. So plug in the 3. Okay.
Yeah.
So it sounds like the factoring wasn't totally, you at least kind of remembered it existed.
Yeah. I
Okay.
remember the purple piece of paper.
Fair enough. Okay, moving on. Okay, so that was the idea of, if you see something that looks like you can factor, try factoring, because there's probably something that can cancel if direct substitution didn't work. Here we're talking about a least common multiple method. Basically, options for how do we deal with a complex fraction like this. Now, as always, officially I'm going to tell you what should you start off with. Try direct substitution. I mean, just by chance it might work. If I try direct substitution here, 0 over 1/4 plus 1 over 0 minus 4. And there we go again, doesn't work. We've got to have a plan B. Okay? So, in order to deal with this, we need to get rid of those fractions in the denominator. Okay? What would be if you were getting a common denominator, what would be that common denominator? Or in other words, the least common multiple of those denominators. One denominator is 4. The other denominator is x minus 4. Common denominator? is just those two pieces
Combined.
shoved together. Okay? So my least common multiple is just 4 times x minus 4. And what we're going to do is I'm going to set this up. I'm going to take my limit. So I'm going to write out my limit here. Limit as x approaches 0 of x over 1/4 plus 1 over x minus 4. So we've got that limit. And we're going to multiply by the least common multiple over the least common multiple. So we're going to multiply by 4 times x minus 4 over 4 times x minus 4. Okay? We can do this, we can multiply by this because we're multiplying by a fraction that's same numerator and denominator, so we're multiplying by 1. We're not changing the value of this fraction or expression, we're just multiplying it by 1. I haven't plugged anything in yet, so I'm still taking the limit, so I still need to be writing the word limit out front. Now, on top, is anything going to cancel or anything? No, it's x times 4 times x minus 4. Or for simpler sake, I'm going to put the 4 and x together and write it as 4x times x minus 4. Okay, it's all multiplying. So you're not trying to distribute the x, you're just multiplying all three pieces together. And then, now what happens on this next piece? 4 times x minus 4 is going to multiply to each of those fractions, right? So 4 times x minus 4 times 1 over 4. What happens there?
X minus 4.
Yeah, the 4 cancels with 4, and you just have x minus 4. Then you're going to have the plus, same thing on this fraction. 4 times x minus 4 multiplied by 1 over x minus 4, what happens? X minus 4 cancels, and I'm just left with plus 4. Okay? A couple of cleanups, and we're going to be there. First of all, does this look nicer? It definitely should look nicer, right? So, on top, for the moment, I'm going to leave it as 4x times x minus 4. Still doing the limit. The denominator? 4 is canceling, you're just left with x. Now, if you plug in 0 right now, we still have a problem. But that's just because there's one more small piece of canceling we can do that will solve the problem. What can cancel? On top, this is 4 times x minus 4. One of the factors is x. X can cancel with x. Okay? It was just like we're canceling the factor of x is what we're doing. So now we're left where we don't have a fraction anymore. The limit as x approaches 0 of 4 times x minus 4. I'm ready to take my limit.
How did the denominators multiply exactly? Like, how did you get x minus 4 plus 4?
So when I multiplied 1 over 4 times x minus 4, in that case, the 4 canceled with 4, and that leaves me with x minus 4. And then plus, and now this time, And you can think of this as over 1. 1 over x minus 4 times 4x minus 4 over 1. This time the x minus 4 cancels, and we're left with the plus 4. Should I write it out, or are you seeing it? Okay. Okay. Okay, so B. Just in case something fun happens, plug in the 0. Does it work? 1 over 2 plus 0 minus 1 over 2 over 0. Shocker.
I don't think I'm ever going to do that part. I don't see the point of it. It's just extra work.
Well, I don't know. I feel like I would in this case just because it's an ugly fraction. And I want to see if maybe there's an easy way out, I guess. But although in this case, you're going to have an x in the denominator, so we have to do something otherwise. So.
Well, do we have to? Because didn't we learn in like 1.2, 1.3 that it could still, if it's like 4 over 0?
That could still exist.
Yeah.
Yeah, so I mean, that's the thing. We can't just stop. But, and that's the thing. I'm saying it wouldn't give me an answer. I'd still have to do something.
Yes, there's no point.
Okay. What kind of least common multiple am I going to want to multiply by here?
Just 2 plus 2 parentheses 2 plus x.
Okay.
Yeah.
So, let's do it. The limit as x approaches 0 of 1 over 2 plus x minus 1 over 2 all over x. And I'm going to multiply by 2 times 2 plus x over 2 times 2 plus x. So I have the limit as x approaches 0. Okay, on top, we're taking this whole piece right here and distributing it. So 1 over 2 plus x times 2 plus x. What happens?
So 2 plus x over 2 plus x.
Well, the 2 plus, yeah, so the 2 plus x will cancel, leave me with 2 minus. On the next one, the 2's cancel, and we're subtracting 2 plus x. Note what I just did. I put parentheses because I'm subtracting 2 plus x. Or you are subtracting 2 and subtracting x. Whatever makes you happy there. Denominator, x times 2 plus x. I'm going to clean that up and make it 2 times x times 2 plus x. What are you canceling?
2 plus x.
Nope.
It's negative and positive.
On top, you're subtracting that 2 plus x.
That's why you did, okay.
And I can't do that when I'm adding or subtracting. It has to be multiples, factors.
In that case, I'm going to put the negative next to x.
So let's clean this up. What is 2 minus 2 plus x? Two minus 2 will cancel, and then you still have a negative x over 2x, 2 plus x. You plug in 0, you're still stuck, but what cancels? The x's cancel. So I have the limit as x approaches 0. I still have a negative on top, so I'm going to write that as a negative 1 over 2 times 2 plus x. Clean it up, and we are at Negative 1/4.
I don't think we're finishing those.
Holy cow, what am I, shoot. I guess
These
I
last
should have
two
been
examples-
skipping something?
These last two examples took forever.
Okay, well, let's see what we can do.
Still got 3 pages.
Yeah, and I know, I need to get through this today. What the heck?
We've done a
I
page
don't-
and a half so far.
Okay. Next. I'm not sure what's going on here, sorry. I feel like I'm going slow, but yet,
We've done all the examples, that's why.
okay. Example 5 talks about the rationalization technique or the conjugate method, okay? As we start looking at this one, okay, they give you a graph there just to show, so officially you can see what answer you should be getting to. But if we plug in -1 there, you end up with 0 over 0, okay? So when you see a square root like that, we need to get that square root out of there, okay? In order to get that square root out of there, we're going to multiply by the conjugate, and it's going to be the conjugate of where the square root is, so the conjugate of the numerator. Okay, so this is, you've done rationalization before, but normally we rationalize the denominator, right? We're going to rationalize the numerator. So I'm going to multiply. Do you guys remember conjugate? If the numerator is square root of x plus 2 minus 1, the conjugate is square root of x plus 2 plus 1. What you do to the numerator, you do to the denominator. Okay? Now, it looks ugly, but I promise you it's going to work. So we've got the limit as x approaches -1. On top, it's a big bad FOIL. Square root of x plus 2 times square root of x plus 2 is
X plus 2.
x plus 2. These are conjugates on top. Your outer terms and your inner terms are designed to cancel. So then -1 times 1, -1. My denominator, I'm not going to FOIL out. I'm going to leave as is. Good stuff will happen. So I'm going to leave it as x plus 1 times square root of x plus 2 plus 1. Okay? We got the square root out on the top, which is what matters. What do you get when you clean up that numerator? X plus 1. What do we have on bottom? Another x plus 1. So what can I do? I can cancel out the x plus 1s. And now I have the limit as x approaches -1. What remains on top? A 1 over square root of x plus 2 plus 1. And now you are doing that direct substitution. So now we're going to plug in the -1. And does that match with what they appear to be showing here? That makes sense, doesn't it? Okay. B is very similar. Tell me what you would multiply by, and then I'm not going to actually work the problem out, but
X plus 5.
no?
3 plus square root of x plus 4.
This time the problem is
Denominator rather than
right, but it could be
square root is. Yes.
It could be either or. That's where the square root is. It's the problem. Okay. So, and that's when we do this rationalization thing, it's usually with square roots. And you want to get rid of the square root. Okay. So you're going to multiply by the 3 plus square root of x plus 4. Okay. Can I trust we can handle the math okay there? I feel like we could.
Yep.
Okay. Let's continue on. And the answer key for these notes is online if you ever want to check an answer, but if you get the mood and you want to go back and work it, there's your answer. Okay? Okay. It says find each of the following limits analytically. Show your algebraic steps.
It's
Okay.
gonna be cube root of 5x plus 1 squared.
And we're going to plug in. Okay? There's nothing really to clean up or simplify here. We're just going to attack it and plug in. And so you're putting in the 3, right? 5 times 3 plus 1. And note, okay, it is, this quantity is squared, and that 3 means it is a cube root, yes? So,
56,
what?
16 squared.
Oh, okay.
Then, let's see, it would probably be 6. I don't know what the is, but
There isn't a cube root of 256.
oh, really?
Wait a minute, pause.
Do you
Okay,
cube it
I'm gonna-
first and then square?
Well, okay, so that's why I had to back up and look. Sorry. There is no cube root of 16. There's also no cube root of 256.
Yeah.
So how I have it written is what we're going to try and do, because this is like a non-calculator type section, so we're not going decimal or anything. Can that cube root of, and actually, you could stop here.
We'll do.
Can the cube root of 16 simplify? There is. What's the perfect cube that's in 16?
8.
Perfect cube, 8, right? And so if you pull that 8, what is the cube root of 8? 2. So you'd put a 2 out front times the cube root of what's left under the cube root? 2.
Squared.
And then squared. You could go one more step if you want.
I don't like that.
You could cube both or square both pieces. The 2 squared is 4, and this could become the cube root of 4. You could have stopped a long time ago.
Yeah.
Okay. Okay. B, I don't know if I'll work all the way through it or not, but you're going to run into a problem if you plug in. You're going to get a 0 over 0. What's the backup plan? Based on what we've learned today.
Well, I would explain it.
And what is that you would be multiplying by?
Square root of x plus 1 plus 2.
And you'll be practicing this in homework, hopefully. So, according to my answer key, final answer is 1/4 if you. Okay. How much time do I have? Like 3 minutes. Okay, so what I'm realizing as we look at these, a lot of these are just, I'm realizing now, these are practicing what we've been doing in variations. Like, for instance, E. There's fractions within fractions. Okay, so that would be one where you could multiply by what? Think least common multiple?
X plus, like x times x plus 3.
Mm-hmm. Okay, we've done that today, right?
Yeah.
Okay, so that's kind of what we're looking at here is some of the special cases.
What's with that absolute value though?
I know, that's why I was trying to, I don't even know that I have time to attack that. That's what I was just looking at. How much absolute value, I wonder, do you? What it may come down to is we talk about those in, there's gonna be some homework questions is what it's gonna come down to. There's gonna be some that make sense in homework and some that don't.
Yeah, I'm gonna call my sister.
Do we need to talk about the squeeze here?
Well, I think I don't know if I can get through it in 2 minutes, but
I don't see any
I
absolute
figure
value in homework.
we'll just do the
Yeah.
homework tonight and come back and talk about the
we'll talk
squeeze.
about it tomorrow.
Just talk about the squeeze
Well,
theorem and the other stuff.
And what the idea of squeeze theorem is that it's saying that if you have this function g, okay, I'll put it in my words. If you have this function g that you know is less than h, but it's more than f, okay, that means it has to go between these two.
Yeah.
It's getting squeezed between the two. The idea then is if you know these limits of h and f, you know the limit of g right there because it's stuck between those two. Okay, so that's the idea that we can look at. And I don't even remember what you have to do with squeeze theorem in homework, if squeeze theorem even made it to homework in all honesty. There's one towards the end. And I'll say, yeah, we'll look at that tomorrow. Okay. Do homework. Come back with questions. We'll do homework questions. And we'll start you guys looking at the quiz review, which is in the notebook.
34?
The quiz review that's in the notebook, you can start looking at that. I doubt you have time, but you know, it's there, it's available. It's probably not available, the answer key is probably not available online, but I will get it available online. Because that's just another folder that's probably there, but nothing in it right now, if I had to guess. Okay? But some of those are gonna go quick.
Squeeze theorem kind of reminds me of geometry side and side. You know, two sides.
Yeah.
Here, definitely.
This must be why I didn't have any notes to myself about, I need to make a note to myself about running out of time on this one though, and pick ahead which ones to skip.
Especially now, if it stays 7.
Yeah.
Have a good day.
Bye, guys.
Yeah, I leave my headphones in here. Does not look good. Okay.
So I don't see them. That feels